What if some of the most advanced technologies in history were already used thousands of years ago? Across the world, there are ancient structures that still leave scientists shocked. Massive domes, perfect geometries, engineering that remains still unexplained. Some of these creations shouldn't even exist for their time, and yet they do. So what exactly did ancient civilizations know that we still don't? In this video, we're going to explore 7 ancient structures that could change what we know about human history. The largest concrete dome on Earth was not built in the 20th century, not even in the 19th. It was poured nearly 2,000 years ago. In the center of Rome, no steel reinforcement, no metal framework, no computer calculations. And yet, it still stands today. Even more surprising, no modern engineer can fully explain why it hasn't collapsed. The Pantheon was built during the reign of Emperor Hadrian around 125 AD. Its dome spans 43.3 meters. To this day, it remains the largest unreinforced concrete dome in the world. For comparison, the dome of St. Peter's Basilica, built 1,500 years later, is smaller, and yet it required metal chains just to keep it from spreading apart. The Romans didn't need chains, because they used a technique that modern engineers only rediscovered in the 20th century. At the base of the dome, the concrete is made with heavy materials like travertine and volcanic tuff, but as the structure rises, the material becomes lighter. Near the top, they used pumice, a volcanic stone 3 times lighter than standard rock. This means the dome gets lighter the higher it goes, not by accident, but by precise engineering design. At the very top, there is a massive circular opening, nearly 9 meters wide, open to the sky. When it rains, water falls directly inside the building, but it never floods, because the floor is slightly sloped, guiding water into hidden drainage systems. The entire structure behaves like a single unified machine. Every detail has a purpose. In 2023, engineers from MIT analyzed ancient Roman concrete, and they discovered something unexpected. Inside the material, there are small lime fragments. For years, these were believed to be defects, but they weren't defects. They were intentional. When water enters tiny cracks in the concrete, these particles trigger a chemical reaction, one that seals the cracks from the inside. The Pantheon can repair itself, and the Romans engineered it 2,000 years ago, long before microscopes, long before modern chemistry. Architects of the Renaissance came here with ropes and measuring tools, trying to uncover its secrets. Filippo Brunelleschi spent years studying the Pantheon before attempting to build the dome of Florence Cathedral. Even then, he made it smaller. Michelangelo once said, "This structure feels less like the work of humans and more like the work of angels." And if it already seems impossible that the Romans were this far ahead of their time, what you're about to see next goes even further. If the Romans were ahead of their time in engineering, what came before them is even harder to explain. More than 1,000 years before Rome, on the island of Crete, there existed a civilization with plumbing, sewer systems, and ventilation. The Palace of Knossos was excavated in 1900 by British archaeologist Arthur Evans. He expected to find the ruins of a primitive fortress. Instead, he uncovered a massive complex spanning over 20,000 square meters, with more than 1,300 rooms. Beneath the floors was a network of ceramic pipes, not just simple channels, but a fully engineered system that delivered clean water from mountain springs while simultaneously removing wastewater. The pipes were conical, narrowing toward one end, and fitted into each other to create pressure within the system, a principle that would only be formally understood in hydraulics thousands of years later. The Minoans used this system 1,500 years before the Romans built their aqueducts. When Evans first saw it, he refused to believe its age. He wrote in his journal that this level of engineering belonged to Victorian England, not the Bronze Age. In the western wing of the palace, he discovered something even more unexpected, a room resembling a toilet, complete with a flushing mechanism. Water flowed from above, washing waste into a stone channel, which then led into an underground drainage system. Europe would not return to this level of sanitation until the 19th century, after the cholera epidemics. But the palace is not just about engineering, it reflects a much larger architectural vision. Light wells provide natural ventilation. Multi-level staircases connect different sections. Columns that narrow toward the bottom create an optical illusion of expanded space. Every detail feels intentional. So the question remains, how does a civilization capable of this level of design completely disappear for nearly 3,000 years? Even today, historians still don't fully agree on the answer. And if their engineering was ahead of its time, what comes next was ahead of its time in a completely different way. If the Minoans were ahead of their time in engineering, the next structure was ahead of its time in something else entirely design. On the western bank of the Nile, in Deir el-Bahari, stands the mortuary temple of Hatshepsut. And at first glance, it doesn't look ancient at all. It looks surprisingly modern. 3 massive terraces rise upward, carved directly into a sheer cliff, connected by long ramps and framed by perfectly straight colonnades, with no excessive ornament and no elaborate curves, only clean, controlled geometry. No other Egyptian temple looks like this, because its architect, Senenmut, created something entirely new. He didn't simply place a structure beside the mountain, he made the mountain part of the structure itself. The geometry of the temple mirrors the cliffs behind it so precisely that it feels as if the architecture is emerging from the landscape. This idea, integrating a building into its natural surroundings, became a defining principle of modern architecture in the 20th century, most famously associated with Frank Lloyd Wright when he designed Fallingwater in 1935. But Senenmut applied the same concept more than 3,500 years earlier. The temple is also aligned with remarkable astronomical precision. On the day of the winter solstice, a beam of sunlight passes through the entire structure, crossing all 3 terraces and reaching the deepest sanctuary, where it illuminates a statue of the god Amun. This means the builders calculated the axis of the temple with extraordinary accuracy, without telescopes, without modern tools, and without digital measurements. Hatshepsut herself was one of the few female pharaohs in Egyptian history, but after her death, her stepson, Thutmose III, ordered her legacy to be erased. Her name was removed from monuments, and her images were deliberately destroyed. Yet the temple remained untouched, because destroying it would have meant destroying the mountain itself. A structure built to honor one woman survived every attempt to erase her from history, and it has stood for more than 3,000 years. And if carving a structure into a mountain already seems impossible, what comes next goes even further. If carving a structure into a mountain already seems impossible, what comes next goes even further. In Petra, an entire city was carved directly into vertical rock, starting from the top and moving downward. Petra, located in modern-day Jordan, was once the capital of the Nabatean kingdom and one of the most important trade hubs of the ancient world. Its most famous structure, Al-Khazne, rises nearly 40 meters high, carved entirely from a single block of rose-colored sandstone. To understand how difficult this is, you have to understand the method. The builders didn't start from the ground, they started at the top. They carved downward, step by step, which means a single mistake at the upper level would have ruined the entire structure. There was no way to rebuild what had been removed. They didn't use scaffolding in the way we understand it today. Instead, they carved steps directly into the rock and worked their way down, shaping the facade centimeter by centimeter. The columns of Al-Khazne are built in the Corinthian style, with a level of detail that is difficult to replicate even with modern tools. But the Nabateans didn't simply copy Greek architecture. They combined it with Egyptian and Mesopotamian influences, creating a style that exists nowhere else in the world. The city contains more than 800 rock-cut structures, including tombs, temples, and dwellings. And even today, less than 15% of Petra has been fully excavated. But beyond the carving itself, there is something even more unexpected. Water. Petra was built in a desert where rainfall is rare. And yet, it supported a population of up to 100,000 people, with fountains, reservoirs, and flowing water throughout the city. The Nabateans engineered a system of channels, cisterns, and ceramic pipes that collected every drop of rainwater across hundreds of square kilometers and directed it into the city. They also developed a waterproof plaster to line reservoirs, a formula that has still not been fully recreated today. When the Romans annexed the Nabatean kingdom in 106 AD, their engineers, who considered themselves the best in the world, were so impressed that they didn't redesign the system, they simply kept using it. And in engineering, that might be the highest form of recognition. But if Petra shows us mastery over stone and water, what comes next pushes geometry itself to the limit. But if Petra shows us mastery over stone and water, what comes next pushes geometry itself to the limit. In Rajasthan, India, there exists a structure that continues to leave modern architects struggling to explain how it was built. The stepwell of Chand Bauri descends 13 levels into the ground and contains more than 3,500 steps, arranged in a perfectly symmetrical geometric pattern. From above, the walls of the well appear almost unreal, resembling a three-dimensional render rather than a structure carved from stone over 1,000 years ago. Each of the four sides descends toward the water through zigzagging staircases, and every single step is aligned with a level of precision that leaves no room for randomness. The structure was commissioned by Raja Chanda of the Nikumba dynasty, sometime between the 8th and 9th centuries. The official explanation is simple. The region's dry climate required deep access to groundwater. But if the goal was only water, why build something this complex? A simple shaft with a rope and bucket would have been enough. Instead, there are 3,500 precisely arranged steps forming a structure that feels almost mathematical in its design. Some historians believe Chand Bauri was more than just a well. They suggest it functioned as a place of meditation, a sacred space where descending toward the water symbolized a journey inward toward enlightenment. At the bottom of the well, the temperature is 5 to 6 degrees Celsius cooler than at the surface, making it a natural cooling system in the intense heat of Rajasthan. People came not only for water, but also for relief from the heat, gradually turning the site into a center of social life. On one side of the structure, unlike the other three, there are no stairs. Instead, a multi-level pavilion was built with niches, corridors, and sculptural elements. This section housed a temple dedicated to the goddess Harshat Mata, confirming that Chand Bauri was designed from the beginning as something more than a functional structure. It was an architectural experience, where a daily necessity, collecting water, became a ritual. What continues to surprise engineers today is its stability. 13 levels carved into relatively soft stone have stood for more than 1,000 years without major structural failure. So the question remains, what kind of knowledge allowed them to achieve this level of precision? And if this already feels impossible, what comes next challenges something even more fundamental. Not geometry, not design, but sheer scale. And if everything you've seen so far challenges engineering, geometry, and design, what comes next challenges something even more fundamental: scale. In Baalbek, also known in antiquity as Heliopolis, lies a structure that continues to defy explanation even with modern heavy machinery. The Temple of Jupiter stands on a massive platform built from enormous stone blocks, 3 of which are known as the Trilithon, each weighing around 800 tons and measuring approximately 21 meters in length. These blocks are elevated about 7 meters above the ground and placed with near-perfect precision, without mortar and without visible gaps. To understand the scale, 800 tons is roughly the weight of 2 fully loaded Boeing 747 aircraft. While modern cranes capable of lifting such weight do exist, they are extremely rare and require months of preparation. Nearby, in the quarry, lies another massive stone known as the Stone of the South, weighing around 1,200 tons. It was partially cut from the bedrock, but never moved, for reasons that remain unknown. In 2014, archaeologists from the German Archaeological Institute discovered yet another, even larger block nearby, sometimes referred to as the Stone of the Pregnant Woman, weighing approximately 1,650 tons, the heaviest worked stone ever identified. The prevailing theory suggests that these blocks were transported using wooden rollers and large groups of workers. However, calculations indicate that moving an 800-ton block on a flat surface would require the force of at least 40,000 people pulling simultaneously. The problem is, there simply isn't enough physical space around the stones to accommodate that number of workers and their equipment. In the early 20th century, French archaeologist Michel Alouf noted that local traditions attributed the platform to giants or supernatural beings, reflecting a long-standing belief that such construction exceeded human capability. While modern explanations rely on labor and persistence, no experiment has successfully replicated the movement and placement of stones of this scale using ancient techniques. There is no need to invoke mythology here, only one honest conclusion. We still don't fully understand how this was done. And if moving stones of this size already seems impossible, what comes next is perhaps even more mysterious, not because of its size, but because of the way it was created entirely by removing material rather than assembling it. And if moving stones of this size already seems impossible, what comes next is perhaps even more mysterious, not because of its scale, but because of the way it was created. In Lalibela, a small town in northern Ethiopia, there are 11 churches that were not built, but carved directly out of solid rock between the 12th and 13th centuries. These structures were created using a method that is the complete opposite of traditional construction. Instead of assembling materials, the builders began by selecting a section of rock and cutting a deep trench around it, isolating a massive block in the center. Then, working from the top down, they carved the entire structure out of that single piece of stone walls, windows, columns, and interior chambers, all emerging from the same mass. One of the most famous examples is the Church of Bet Georgis, dedicated to St. George. It is carved in the shape of a perfect cross and descends approximately 12 meters into the ground. When viewed from above, it appears as a freestanding structure, sitting inside a rectangular pit, with clean vertical walls cut into volcanic rock, almost like a ship resting in a dry dock. All 11 churches are connected through a network of underground tunnels and passageways, forming a labyrinth that can easily disorient anyone unfamiliar with it. The entire complex also includes a drainage system designed to direct rainwater away from the structures, preventing erosion and preserving the integrity of the stone. The orientation of the buildings reflects careful planning, taking into account both cardinal directions and natural water flow. According to Ethiopian tradition, King Gebre Mesqel Lalibela ordered the construction of this site as a New Jerusalem after the original city was captured in 1187. Legend claims the work was completed in just 23 years, with angels assisting the builders at night, doubling their progress. Setting aside the legend and considering only the physical work, the scale becomes difficult to comprehend. For just one structure like Bet Georgis, approximately 500 cubic meters of rock had to be removed. For all 11 churches, along with the surrounding trenches and tunnels, the total volume reaches tens of thousands of cubic meters, all carved without steel tools, explosives, or mechanical assistance. In 1521, Portuguese monk Francisco Alvarez visited Lalibela and wrote that no one in Europe would believe what he had seen. He was right. His account was dismissed for centuries, and the site remained largely unknown to the outside world for nearly 400 years. Even today, despite being recognized as a UNESCO World Heritage Site, Lalibela remains unfamiliar to many outside of Africa. Yet the churches are not abandoned ruins. They are still active places of worship. Every Sunday, priests, dressed in white, descend narrow stairways carved into the rock and hold services in the same spaces that were created centuries ago. Lalibela was never turned into a museum. It remains a living structure. And perhaps that is its greatest mystery. We have now traveled across 7 locations, separated by thousands of kilometers and thousands of years, from Rome to Crete, from Egypt to Jordan, from India to Lebanon, and finally to Ethiopia. Roman concrete, Minoan plumbing, Egyptian architectural integration, Nabatean rock carving, Indian geometric precision, Lebanese megalithic construction, and Ethiopian subtractive architecture. Each of these represents a level of knowledge that, in many ways, still remains difficult to fully explain. What is perhaps even more surprising is that none of these technologies were directly passed on to the civilizations that followed. Each time, knowledge appears, reaches a peak, and then disappears along with the culture that created it. The formula for Roman concrete was lost after the fall of the Roman Empire and has still not been completely replicated. The hydraulic systems of the Minoans vanished after the volcanic disaster on Santorini. The Nabatean mastery of carving stone faded as trade routes shifted and Petra was abandoned. We often think of progress as a straight line, moving from simple to complex, from primitive tools to advanced technology. But these structures suggest something very different. Progress may not be linear at all. It may be uneven, with peaks of knowledge that we still cannot reproduce, followed by long periods where that knowledge is lost. Perhaps the real mistake is not that history is wrong, but that it is simplified. It draws a smooth road where, in reality, there may have been a fragmented path full of sudden breakthroughs and unexpected declines. And if knowledge can disappear with civilizations, then each of these sites is more than just a historical landmark. They are warnings, reminders that even the most advanced technologies mean nothing if they are not preserved and passed on. We don't know what knowledge we might lose tomorrow, or how many centuries it would take to rediscover it. But one thing is certain: anyone who dismisses ancient civilizations as primitive has likely never stood beneath the dome of the Pantheon or touched the walls of Lalibela.